All right, so this is the last video lecture for Unit 3 on nonlinear systems of inequalities, right? So it's going to be very similar to the one you should have just watched for 3.9, but now we are dealing with inequalities. So if we look here at our overview, okay, so talking about curve functions still, but also non-linear inequalities. So, right, putting together two of our favorite things, and then trying to solve them as a full system here. All right, so moving forward with the study, again, let me point out here, there's only one quiz, so woohoo! Let's rock and roll and finish this out strong. All right, so 310, let's get this started. Okay, for the study here, so the nonlinear system of inequalities, all right, it is similar yet different than the nonlinear equations, all right? And we can highlight some of the difference here, and they might have the same shape, right? They might have the same shape if they have the exact same expression, but whether it's an equal sign, greater than, equal than, less than sign, right? That's going to determine based on if there's shading, what that shading looks like, if it's a solid line, if it's a dashed line, and we'll talk all about that in the next couple of slides here. All right. Now, remembering, okay, if an equation has an equal sign, you draw it as a solid line. All right, and if it has a greater than, equal than, less than sign, you show it based on shading, right? You show it based on shading. And the area that you shade is going to be determined based on if it's greater than or less than. Okay, and the way that we can check to see what we shade is to see if a point on the graph makes the inequality true or false, right? So for example here, if we looked at x squared minus 2, which is not shown, but if we look at x squared minus 2, it's got to be less than y. So if you plug in 0 2, right, if we plug in 0 2 here, 0 2, if we calculate this out, 2 is greater than negative 2, so that value would be true, right? So that would be part of the solution set. That would be part of the area that gets shaded. Now if we look at 4 negative 1, we plug that guy in, 4 negative 1, that one is false or not true, okay? So that would not be part of the solution set, so therefore that would not be part of the shaded region, okay? So if we were to look through this here, okay, we would look for and we would plug in all of these different points. So yes, yes, no, yes, no, yes, right? And what you're going to find out here is there seems to be a group or a region that is all yeses, right? And when we actually look at the equation, or when we look at the expression itself, right, we can plot that expression as a line, right? We can plot that as a line. But it's when we get this inequality symbol where we have to consider the shading, and we have to consider, again, you can see now this is a dashed line, okay? But this now is showing that the shaded region are all the points that are included in the sample set. All right. So let's point out some differences here, okay? So we said if you've got a greater than an equal to or less than an equal to sign, it is a solid boundary line. All right. If it is just a greater than or less than sign, it is a dashed line. And then if it is an equation and not an inequality, right, there is zero shading. So for example, these are all going to have the same expressions, but it's going to differ based on the inequality symbol. So here's what our original looks like. All right. If we are less than that, right? If we are less than that, so we shade the region underneath. All right. And this is actually less than or equal to, so we keep the solid line. If we are just less than, we still have that same shaded region, but now our line becomes dashed. Okay, if we go back to our original, now we're going to be greater than or equal to. So now we are inside, right? We are greater than and equal to. So solid line shading inside. If we are just greater than, it is a dashed line, but still shading on the inside. Okay, so then again, how to graph an inequality here, the main steps. Okay, it's nothing different than what we've done for graphing parabolas here, okay? Nothing different for the first main steps, okay? So we've built up to this point. We've got to find the x-intercepts in our function. So if we're given this function here, right, we can use our quadratic equation. We can use our factoring method, right? And so for this one, it was easier just to factor, right? And we were able to find that these are our solutions, and we know that our solutions are our x-intercepts if we put them in coordinate pairs. So we find the x-intercepts. Find the vertex, right? And the vertex is found by using the equation negative b over 2a, right? We use that to solve for x, and then we plug that back into our equation to solve for y. So that gives us 3 points. If we can, right, if we can find the y-intercept of the function, right, and we do that by letting x equal 0. All right, so when x is equal to 0, we can solve for y. That now gives us 4 points. That gives us 4 points, and we can feel pretty confident about the shape of our parabola here. So we put the points and we sketch our curve. All right, then we have to look at the boundary lines of our inequality. All right, so are they greater than, or is it greater than and equal to? All right, if it's greater than and equal to, we then have the solid line. If it is just greater than, it becomes dashed, right? And then what we can do is we can typically choose a point, right? And we usually choose the origin point, 0, 0. But you choose a point here and you see, okay, does that point pass or fail the test? If it passes, that's included in the region that you shade. If it fails, it is in the non-shaded region. Okay, and you're going to shade, again, obviously the appropriate region there. All right, we'll skip this one for now. All right, so then when we're looking at nonlinear systems of inequalities, we are looking for where the shaded regions overlap. Okay, so we have one parabola here with purple shaded there, so that's an inequality. We have a linear line here, that's an inequality. So if these were just equal to, we would have 1, 2 possible solutions. But now we have multiple solutions, and it's this purple shaded area, right? Okay, so for this one here, it's showing you a diagram of a theater, all right, known for its acoustics. So an avid fan ended up plotting this and found out, hey, I'm looking for the best acoustics here. All right, and it's got 2 expressions. It's what he used to make these. All right, f of x is equal to negative x squared plus 8, and f of x is equal to x squared minus 8. All right, and to figure out what the inequality is, you can do multiple things. You can look at this and understand the directionalities. You can look at this and you can plug in values, right? And you could plug in 0, 0 and see if that passes or fails when you have the different inequalities. All right. So the solution set for an inequality is the shaded area, right? It is the shaded area. A nonlinear inequality is a nonlinear equation, but instead of an equal sign, it's now a greater than, less than, or greater than or equal to, or less than or equal to sign. All right. So then all the points that are shaded satisfy that inequality. All right. How do you graph a nonlinear inequality? You follow these 5 steps here. All right, so you replace the inequality with an equal sign. You graph the resulting line based on your x-intercepts, your y-intercept, your vertex, right? Then you make either a solid or a dashed line depending on the inequality. You pick a point to figure out if it's going to pass or fail your inequality. If it passes, that's part of the shaded region. If it doesn't, that is the unshaded region. And then you shade, again, you shade the appropriate region, noting that the boundaries may be shaded or dashed. All right, then the nonlinear system of inequalities is multiple inequalities with 2 or more variables. Again, we're looking for the regions where they are overlapping, so the shading is overlapping. All right, so when we're looking at these guys here, again, you've got to look at 0, 8 is that vertex point, okay? And we've got to look to see if it's going to pass or fail, right? We're going to look to see if it's going to pass or fail. So if I choose 0, 8, right? If I choose 0, 8, it's going to be on the line, right? And we can see that it's a dashed line. So there's no way it can be A, okay, because it's a dashed line. Because we have shading, it cannot be B because B is equal to. And then what you look here, it says X is greater than Y. So if I plug in 0, 8, if I plug in 0, 8, I've got 0, Y is 8. So this is saying negative 8 is greater than 8. That's not true. So our answer there has to be D. All right. So then again, for the inequality, you would have to plot the points, pick the shading. If you're going to do this graphically, if we are just going to look at an equation and you're given coordinates, what you can just easily do here again is just plug in the x coordinate, plug in the y coordinate, execute, and see if it passes or fails. All right. For this one, what inequality must match the graph? I can pick out two things immediately that are going to cancel out a lot of these options. First thing, there's shading, so it cannot be option A. Second thing, it's a solid line, so it has to be greater than or equal to or less than or equal to. So right now, we've already eliminated it down to letter D and E, okay? And then finally, the last thing is check a point. So if we want to check 0, 0, okay, if I plug in 0 and 0, we can check and see. And in this case, 0, 0 should not be included, so that should fail the inequality, right? That would tell you that would be the appropriate inequality. Okay. Same thing here. You're going to look for two inequalities. Okay, you're going to look for two inequalities. So that would be the first two, second two, right? You're looking for two that match. So again, figure out which one stands for which, test the points, make sure that it matches, right? And go from there. All right. Here's an interesting one that we haven't seen yet. Okay. It's a solid line and a parabola. Okay. So again, knowing which one is which. So your solid line is y is less than or equal to 5. Okay, less than or equal to 5. So it automatically has to be a solid line. So you've eliminated option B. Okay, then your parabola is got to be greater than. So immediately we eliminated option A. So you're left with C and D, and you got to figure out, well, it's got to be less than 5 but greater than this. Well, I can determine this based right off the bat. It's got to be less than 5. If this line is the line for 5, right? It's got to be underneath that. So it's going to be option C. All right. So again, that concludes part 1 here, and then we're going to go to your study guide here and walk through some of those answers. Okay, so for your study sheet here, the first question is talking about the boundaries between two regions is the curve, right? So we got to fill in the blanks with the correct inequality symbols. So for a solid curve, the inequality is greater than or equal to or less than or equal to, right? That would make it solid. If it is dashed, that means it is just greater than or less than. Okay. For this inequality below, okay, for the inequality below, you would have to, again, find the vertex, right, which we can do by using our cheat equation, right, negative b over 2a for the x component, plug that back in for the y component, right? We can then figure out, for this one, we can figure out our y-intercept, right? And then we know that the y-intercept has to be reflected along that axis of symmetry since there is no x-intercepts. Okay, so it's reflected. We have 3 points we can connect and make it our line, right? And then again, it's a solid line because it is less than or equal to. And since it is less than, the shading has to be underneath. All right. Listing the points in the graph that satisfies each inequality, right? So you can look through here and look at all the letters. I don't want to read it out and confuse you, okay? So the ones that will satisfy the different graph here. Okay, so again, it's looking at if this is the straight line, if I change the inequality, which points then satisfy that inequality, right? And you have to pay attention to, like, A is on the line, so is F. So you have to understand if it's included or not included. Okay. For the next one here, you can take a look at these images. They do a really nice job of shading and coloring and making it very, very obvious as to what's what. So again, especially this one down here. Okay, so the region that would be satisfied would be all of this purple region, okay, excluding this region here in white. All right, and we'll go through a couple examples here on your checkup. Again, reminder, there's only one quiz. Do your checkup, and then the only section that's left is 311, and we will cover that because that is your review and your test for this unit. So we'll cover that on Monday. So make sure you get to this point. You're completely ready to go, and if you have any questions, we will address them come Monday. But let's get to the checkup here. Okay, so we're going to go through some of the checkup, and we might spend a little bit longer on this checkup than normal because I want to make sure we understand what we're doing when it comes to graphing. So we're going to match these graphs to their appropriate equation. So for this one, actually, it's pretty simple because they're all the same graph, right? They're all the same graph, or at least, sorry, they're all the same expression, right? So they're the same expression, but really it's changing the inequality with it. So I can point out a couple things here. All right, so this is a solid line and this is a solid line. So this automatically is greater than or less than, greater than or less than. All right, and for me, I can notice here that this is included. It's above. So to me, that is greater than. So y has to be greater than. So the answer for this one is y is greater than or equal to that following expression. So that is graph A, which means that the only option for graph D is y has to be less than or equal to. So this one here is graph D. All right. Using the same logic here, that means that this one is greater than, and this one is less than. So for here, less than, this would be graph B, and this would be this would be graph C. All right. Now here, graph the system of nonlinear inequalities and determine if a given point is in the solution. Okay, so this one is going to be pretty involved here, so stay with me. All right, now the first one here says graph y equals x squared minus 4. So in order to do that, we've got to find a couple points here. All right, so what we can do is for this first one, we can set x equal to 0, right? So if x is equal to 0, y is equal to 0 minus 4. So y is equal to minus 4. So our y-intercept is at 0 minus 4. So let me make a plot, 0 minus 4. There's our y-intercept. All right. Now, if y is equal to 0, 0 is equal to x squared minus 4. All right. Bring 4 to the other side. Square root. So we've got x is equal to plus or minus 2. So our coordinates are 2, 0 and negative 2, 0. So we've got 2, 0, negative 2, 0. And wouldn't you have it, if you look at it, okay, again, we went over 2, and that makes that this y-intercept here is our vertex as well. So this is actually our vertex as well. All right. Now, we have 3 points, so we can make a line. Now, the question is it going to be a solid or a dashed line? And the answer is it's going to be solid, right? So we're going to have a solid line. I'm not the best artist, so I don't expect you to be either, all right? Now we've got a shade to show that y is greater than. So if we're going to test a point here, we can test 0, 0. All right? So is 0 greater than or equal to 0 squared minus 4? So is 0 greater than or equal to negative 4? The answer to that is yes. Okay, so that means this is the region that we're shading. All right. Ooh, that bothers me. Let me fix that here real quick. All right, this is our shaded region. Now, if we go to the next one, graph y equals x plus 1 to show the next inequality. So I'm going to erase my work here to make space. All right, we're going to solve again for this equation here. So y is equal to 0. That means that 0 is equal to x plus 1. So x is equal to -1. So our intercept is -1, 0. So -1, 0. All right. Apologies, I messed that one up. That was confusing me for a second here. -1, 0. There it is. Sorry, my apologies. Got lost there for a second. All right. Then if I make x is equal to 0, y is equal to 0 plus 1. So at 0, 1, we also have a point. 0, 1. All right. And this is actually a straight linear line with a slope of 1. So we go up 1 over 1, up 1 over 1. All right. So this ends up being our linear line. All right. And I know that it's a straight line because it is less than or equal to. All right. Less than or equal to. So then that's the last thing. It's less than or equal to. So if it's less than, it has to be below this line. So everything below this line is included. All right. Identify the region that shows the solution to the system of inequalities. Well, that's going to be this region here, right? That middle region, that overlapping region. So right there. All right. Is 1, 1 a solution to the system? Why or why not? Well, let's look on our graph here. If I get rid of those lines that I just made. Is 1, 1 a solution? We go over 1, up 1. So that would be right there. The answer is yes. It is a solution. Yes. And you can say because it's in the overlapping region. Right? And that means that it's included in both inequalities. All right. For this one, identify the system of inequalities shown in the different graphs. Okay, so this is now working backwards here. This is now working backwards. So putting literally everything we have done together to figure out what are these different lines and then what makes them the inequalities, right? So if we look at our linear line here, okay, at x equals 0. At x equals 0, we have y is equal to +2. All right, so that means for our linear line, y equals mx plus b, right? Y equals mx plus b, our b value, we just found out, is 2. All right, now we need to figure out what our slope is. Our slope, and again, it goes... Our slope, which is m is our slope, which is our change in y over our change in x. So how many up do I go and for how many over? And I'm looking, it's 1 to 1. So I'm up 1 over 1, up 1 over 1. So it's y equals x plus 2. So that's my first line there. Y equals x plus 2. All right. But we have to figure out, that's the line, what is the inequality? If that's the line, what is the inequality? Well, it's a solid line and it's shaded above. So y has got to be greater than or equal to x plus 2. Right? So that's the first one we figured out. And let me change the coloring for this to make this obvious as to which line I'm talking about. I'm talking about the blue line. Okay, now if we solve for our red line here, we are looking at a parabola. All right, we are looking at a parabola. And our parabola has a point x equals 0, y equals -3. All right, y equals -3. All right. Okay, so moving forward here, now that we know y equals -3, we know we have a coordinate at that location. All right. And that is actually our vertex point. So that is our vertex point. All right. And we can tell that it is symmetrical, right? We can tell that it's symmetrical. And we end up with our equation, our normal equation, y is equal to x squared minus 3. All right, x squared minus 3. All right, and if that's our line, right, again, it's shaded above. So what we write is greater than or equal to x squared minus 3. X squared minus 3. All right. And again, the reason we can tell this is because it is a perfectly symmetrical parabola, okay? And it has been just shifted down 3. We have no stretching, we have no elongating, we have no moving. The only thing we did was we moved it down 3. So all we do is we take our x squared and we move it down 3. All right.